All right, let's talk about your first slide here. The first point you make, start with the best theory of everything available. I think cosmology assumes that the best theory of everything available is general relativity.
General relativity, of course, is excluded by my own study in 2011 of lunar laser ranging is just one of many studies, as Ian Cohen has previously pointed out, that exclude general relativity. So general relativity, as far as I'm concerned, is off the table. It also violates another one of my rules, that if you look at the general relativity, I guess you call them field equations, C is an input parameter. Well, how can you use an unexplained measurement? Again, that's like trying to do calculus when you haven't mastered algebra yet.
Okay, I'd like to move
You're
on
sort of
to
doomed
your
to fail.
I'd like to move on to your third point. Assert conservation laws which postulated events confirm, such as conservation of energy. So my question is, and I'm not sure whether you've said this or not, does binary mechanics assert conservation laws?
Yes, it asserts that there is the conservation of energy because in none of
Hold
the
on, hold
equations.
on. Is that just an assumption on your part, or is that a theorem? An axiom is or a postulate is something that you assume to be true that goes into the mathematics. A theorem is something that you prove from the postulate. So is that a postulate or a theorem?
The actual equations, time development equations of binary mechanics, conserve the number of one state bits. There is no case of annihilation of one state bits anywhere or creation of them. So that's energy. Your one states represent energy. And so that we have the conservation of energy. Our wonderful Dennis Allen Jr., who is one of our CNPS participants that everybody I think knows, pointed out that there is a violation in the inertial propulsion phenomena of the conservation of angular momentum. And this was very educational to me because I said, wait a minute. I looked at my equations of binary mechanics, and there's nothing in them which prevents angular momentum from being converted to linear momentum or vice versa. In fact, the whole mechanism of motion, which I presented in a previous Sunday session right here, shows exactly that going on. So that people like Dennis Allen have helped me understand and better present what these equations are saying.
All right, let's move on to, that was a good answer. Use unexplained measurements. Okay, so now you're calling the constants of physics. They call these things constants. C, E, that would be the electron, H, Planck's constant, etc. You made a statement that you derived these constants using binary mechanics. The other comment that you made previously about this was that they're not an independent set in mathematics. They don't form a linearly independent set. So you've apparently looked at this issue pretty closely with binary mechanics.
What I did with the postulate of full quantization of space-time and energy in binary mechanics, but to me, it's inescapable logic that if you're quantizing these three parameters, which are the units of measurement in physics, very basic things here, to ask the question, well, what are the values that they have? And so what I did was a process of reverse engineering the equations or expressions for Planck's constant, speed of light, elementary charge, and so forth, to come up with these values. And as far as I know, these are the only possible values which satisfy all of these equations. So that the information dense slide that I showed you, the derivation of the constants that Harry said rightly is information intense. But if you look at that, you can say, is there any other set of values for mass in kilograms, length in meters, and time in seconds that simultaneously fulfills or solves these equations presented? It's a purely mathematical problem. Now, maybe a mathematician who's better than me can actually prove that there is only one set of values. I'm claiming that just simple logic tells me there could only be one set of values which satisfy all of these equations. But that's sort of an intuitive conclusion from a person who's not claiming to be a professional mathematician. I'd like a professional mathematician to chime in. Yeah, Jerry.
Well, I think you mentioned earlier that the Planck scale isn't valid. Did you say that?
Yes, because those values are based upon unexplained measurements. So the Planck values are just more unexplained values because they're based upon unexplained values, okay? That's simple logic. And by the way, they're inconsistent. They say the laws of physics would no longer apply below the Planck length, okay? Well, what about the Planck mass, Jerry? The Planck mass is a huge value. Everybody accepts reasonable measurements for electron mass and proton mass in kilograms, and that's far below the Planck mass. So you see, there's no logical consistency in applying the Planck values for length, mass, and time, because in one case, they say if it's below the Planck length, then the laws of physics don't apply. But in the other case, if it's below the Planck mass, they don't say the laws of physics don't apply because everyone agrees that a proton mass is orders of magnitude less than the Planck mass. In other words, it's all a sinister fiction.
As far as the Planck scale goes, I mean, I don't know if it was based specifically on something in particular or if it was just somewhat arbitrary, but I looked it up.
It's based upon these unexplained measurements, Jerry.
Okay.
Just look up on Google the Planck limits or the Planck constants, or the Planck length and so forth, and you'll see it's what I have called in previous slides and presentations a magical mystery tour, which is totally inconsistent because, as I've said, the proton mass is orders of magnitude less than the Planck mass, but they don't say that protons don't exist because of that.
James.
However, for a length less than the Planck length, they say that the laws of physics may not apply anymore. You see the inconsistency there?
Yeah.
In other words, let's be logical.
James, have you used this model to test other models? Because it seems like this model would be a good model to test other cosmological models and other models of physics.
Well, the binary mechanics simulator software is at this time at least is a free download. It won't be free forever. Get it while it's free, and do some tests. You know, what we need is some minds like we see here today, asking penetrating questions. So we have a great selection of intellects here. By the way, the electric theory that you are a proponent of is included in binary mechanics, but binary mechanics would allege that it's not complete because it leaves out the unconditional bit operation and the strong bit operation. Any phenomena that you're talking about, or anybody is talking about in physics, when you get down to it in binary mechanics, it must be made of quanta in some, because that's the only thing available to make anything out of.
How was the binary mechanics, like the discrete units as far as distance or increments of time? How was that arrived at?
If you're going to quantize space, energy, and time, the next logical question is well, what values do they have? You know, in kilograms, meters, and seconds. So part two of the answer is once you apply that logic which says that they must have some particular values, you can start to reverse engineer. And this took me several years of work on and off of looking at all of these equations presented in my primary constants derivation slide, and to reverse engineer that to get the values that I presented. So in other words, you don't have to get a UFO that crash landed and start to look for the technology. Just the universe around us, the environment around us, is the advanced technology that we need to reverse engineer. And that's what binary mechanics is looking at.
I would be very much interested to hear how the reverse engineering was done.
Good talk, James. Good talk.
Oh, absolutely.
Well, the
Okay,
reverse
and here-
engineering was done by eliminating any contradiction in that slide of all of the equations, which is titled the physical constant derivation tree.